Let's start the class. This is GATE Aerospace 2025 batch, and this is day 3 of the batch, and aircraft propulsion is going on. And I have started with thermodynamics. Today's topic is going to be temperature. So in last class we have seen details regarding different types of pressure, and it was a very good lecture. Today we will discuss about temperature. What do you mean by temperature? Do not be confused with heat. Okay, so suppose I say that in this vessel I have, in this container I have some any matter, for example any fluid, for example water. Now see, in wrong way you can say that how much heat is present, how much heat is present in the water. This is a wrong statement. Okay, now I can say how much heat is being transferred from outer source to the water. That is correct. What is the level of temperature here? That is also correct. I can ask, you cannot ask what is the heat of the water. That is wrong. But you can ask what is the temperature of the water. Okay, so first of all, temperature is a point function, state function we have seen in previous classes, and we have also seen that heat is not. But understand, whenever you supply heat, temperature of the body changes, but not always. See, I am saying something. I am saying a statement. Whenever you are supplying heat, Q is the symbol for heat, temperature of the object will increase, but not always. You know why? Because heat itself is of two types. One heat which is changing the temperature, and one heat which is changing the phase of the matter. Solid to liquid, liquid to gas, gas to plasma, plasma to EB, like that. Okay. Now, here I am discussing about temperature. When you supply heat, there is chance that temperature will increase. We will see why there is temperature present in the object and what do you mean by 0 Kelvin temperature. Very interesting fact. I am changing the page. Okay. I'll check my camera is working or not properly. Yes, it is working properly. So now I'm saying, suppose you have any object and the blue color what you are seeing, consider this blue color is not a solid thing. Consider this is a liquid element. And imagine a hypothetical situation. You are inserting a thermometer in this liquid element, and you are reading as 50 degrees Celsius. Now question is, why there is temperature present in the object? So answer for that is, temperature is there, everything is hot or cold, something. What is the main cause? Because of molecular energy. Molecules are having energy. What kind of energy? That energy we say average kinetic energy. Why I am saying average here? Because every molecule will be having different types of absolute velocities. So we go for their RMS velocity, and according to that we find out average kinetic energy present in the liquid element because of molecules, right? That kinetic energy you cannot measure at molecular level every time. In our daily life, I cannot, suppose I have a water bottle, and in this water bottle H2O molecules are there. Now those molecules are hitting each other, they are bombarding on the wall, and some molecular phenomena of hitting, momentum transfer, these things are taking place. Because of that, I don't do all those things. I don't discuss all those things, right, every time. So what do we discuss? We discuss temperature. What is the temperature present? So it means what? Temperature is nothing but the measure. What is temperature? It is measure of average kinetic energy of the molecules, right? So it means kinetic energy of the molecules kinetic energy of the molecules is connected with temperature, right? So we should know one basic formula. Again, I am saying this formula we are not going to use in GATE Aerospace. This is a fundamental concept. Why something is hot or cold? What is the definition of temperature? It is nothing but it is measure of hotness or coldness of any object. Okay, let's understand like this. Imagine a situation I am giving you a diatomic molecule. I am giving you a diatomic molecule. Suppose this is my diatomic molecule and I am keeping them in this system. And I am measuring certain temperature that is coming as T1 is equal to suppose 100 degrees Celsius. Okay. Now you know what? If you supply some amount of heat, then what will happen? Temperature of the object will increase. It will become T2. Suppose it will become 200 degrees Celsius. Now when temperature is changing from here to here, what kind of molecular phenomena is changing in the system? Let's understand that. You know, if molecules are having less temperature, then they will only go in a straight line, here and there, here and there. They will do zigzag motion and they will hit each other. Simple. Okay, one type of motion that we say as translation or translatory motion or linear motion. Okay, but second point. Now, if you will give them little bit more heat, heat is a form of energy. So those molecules will accept that energy, and if there is energy supply, then definitely that energy will do something, because now they are getting more energy. They will do something. What will they do? They will add some more form of motion. So second form of motion they will add. What is that? They will start rotation about each other. About this axis, this set of molecules will rotate. About this axis, this set of molecule will rotate. At low energy, at low temperature, this motion was not present, only translation was present. But now I am giving you more heat. Because of that, more energy is being transferred. So more types of motion will introduce in the system among the molecules, right? That will give you more kinetic energy. Because of that, you are measuring more temperature. Now suppose I am supplying more energy, more heat. I supplied more heat. If you will supply more heat, then you know what will happen? Translation is already there. Rotation is already there. Plus vibration will also start among the molecules. What kind of vibration? One molecule and another molecule, they will vibrate towards, to and fro with respect to this position. It's like they will come here and they will go away. This kind of vibration will take place. And in same way, if you will supply more and more heat, then what will happen? These molecules will break, they will convert into atoms, and those atoms will be in ionized state. That's why solids, when they convert into liquid at more temperature, their molecules are more free because of this phenomena, right? And that's why when you heat up the gas becomes ionized gas, right? This is the phenomena. I hope you understood how temperature. Which part do you want me to repeat? I will repeat for sure. Unmute and say. Ask your doubt, I'll explain. Ionized, okay. Feel free to talk, guys, no problem. Suppose I have any gas that is HCl. So I have one HCl molecule. I have another HCl molecule. I have another HCl molecule. These molecules are stored in a container. Currently, I am giving you a energy. Because of that energy, I am measuring certain temperature. Now, I am supplying you more heat energy. I am saying heat energy. Because of that, temperature is increasing, right? Now, if you'll keep on supplying heat, keep on supply, then what will happen? These molecules will break. H will be separate and Cl will be separate. And because, if you know chemistry little bit, there was bond earlier. So H plus and Cl minus. So now, earlier it was a pure HCl. Now it became ionized gas at more temperature. That's why you can clearly see motion of the molecules are actually increasing. And where it is going, finally molecules are breaking. They are converting into ions. You know, further if you will supply heat, what will happen? It will convert into plasma. Further if you will supply heat, what will happen? It will convert to EB state. Okay. There are, like I said, mainly we have two states of matter. One is solid and one is liquid. If you will study liquid again, you have, I'm very sorry, solid and fluid. Now, if you classify fluid, then again you will be having liquid, gas, plasma, Einstein-Bose, and in this also you have subcategories. No need to go into that detail because that is out of our syllabus. So I'm stopping here itself about the temperature. So you should know difference between state and phase. No. State and phase. See, if you are in liquid state, what is your phase? That is liquid phase. Now on diagram, suppose I'm having a PV diagram. So you are here, okay, and now here pressure is P1, velocity is V1, sorry, volume is V1. Now you are coming here. Now this became a new state, but still you are liquid. Still your phase is liquid phase. Now you are here at P2 V2, P3 V3. Still you have same phase but state change. Priyanshu, do you understand now what I'm trying to say?
Yes, sir.
Very good. This was a good explanation. Now see, I am going to give you some more basics about temperature. See, you should know about something called Boltzman constant. This Boltzman constant value is Kb is the symbol for Boltzman constant, and its value is R universal gas constant divided by Avogadro number. We know that universal gas constant value is 8.3143 joule per mole Kelvin. Okay, and if I divide this entire value with Avogadro number, 6.023 into 10 to power 23. Some people may write here 2 also, that is totally fine, no problem. Molecule per mole. See guys, try to understand what is difference between molecule and mole. Okay, see, mole is the unit to measure matter, but molecule you know very well. When atoms combine, they form a molecule. For example, H2O. Here I have one molecule, but 2 atoms of hydrogen and 1 atom of oxygen. So I have total 3 atoms. 3 atoms I have, but only 1 molecule. So if I am writing this number 6.023 into 10 to power 23 molecules divided by mole. Do you understand the meaning of this? These many pieces of molecules are present in 1 mole. So do you understand now what is mole? Mole is unit for matter. If I say that I have 1 mole bikes, if I say I have 1 dozen bikes, it means I have 12 bikes in my home. If I say I have half dozen phones, it means I have 6 phones. If I say I have 1 mole phones, can you imagine what is the number 1 mole? 1 mole number is a very big number, very big number. Order you check, 10 to power 23. This much high number. I hope you can relate this in real life so many places. Can someone tell me what is the, just Google it, what is the population of the world? Anyone? Even I will check. Guys, just comment.
Says 7 billion.
7 billion, okay. Then I will not check because you have checked. So now you tell me how many zeros will come in billion. Don't you think 9 zeros will come?
Yes, sir, 9.
Okay. So, okay, roughly like that, whatever, 8.1 billion or something, 7 billion. So you check the order, you check the billion part, you check, don't check the number. So 10 to power 9, that's all. Only this is the population of the world. But you try to understand what is this 10 to power 23. 10 to power 23. Just do one more check. Just Google in kilometer what is the difference, what is the distance between sun and earth. Check in kilometer. Then you will see the, like, this is a big order. This order 10 to power 23 is a big order. Anyone? 10 to power 15 kilometer. Are you saying that? 10 to power 15? Okay. Great. So, now if I will erase all these things, because this was just basics I wanted to explain, I will go back to the concept of Boltzmann constant. You relate this answer. What is Boltzmann constant? If you solve this, then you also check your units. Don't you think mole and mole will get cancelled? Yes. Then what will be remaining? 1.38043 into 10 to power minus 23 joule whole divided by what is remaining here? Molecule and Kelvin is remaining here. So molecule and Kelvin. Guys, whenever you are writing unit, be very, very comfortable. And students who are not good in units, convergence of units, work on that. Do some homework, go for some NCRT or do on YouTube or Google something, but be very strong at unit conversion. So you understand this much joule, which is actually minus 23, so very less joule. This much joule energy is present in one molecule. And when you change every Kelvin, every 1 Kelvin temperature, this much energy will change in every single molecule. Now try to understand the idea. Suppose I have a system. In this system, I have molecule A. I have another molecule A. Now, see guys, this is average. Okay, if I change the molecule to molecule B, this data will change. But we are talking about average. On average, how much energy goes? Because already number is very, very less. Okay. So currently, if I say that for per Kelvin, this much energy will be added in every single molecule. I hope you understand that. Guys, clear, right? If I increase every 1 Kelvin temperature, then in every one molecule. Okay, thank you, Kajal. So this one energy, so this is the value of actually Boltzman constant. That's why this value is very famous. Anyway, you should not remember this value. So when you are revising for the GATE exam, don't revise this part. This is just out of interest. Everyone should know, whoever is learning thermodynamics. Now let's jump to the property, some important property. You may have heard that people say that specific means, for example, if I say specific kinetic energy, when the word specific comes into picture, try to understand what is our basic mindset. Kinetic energy is half mv square. But because m is present here, so this kinetic energy belongs to the entire mass. So it means it is total kinetic energy. But if I will divide both sides, so right now what is the unit? Joule is the unit. I'm sorry if I'm doing any spelling mistake. So kinetic energy is half mv square, that is for the entire mass. Now let's divide this answer by mass and this answer also by mass. Then what is remaining? Kinetic energy per unit mass is nothing but half v square. So now unit will become joule per kg. Many GATE students are appearing in GATE exam and they are weak in these kind of unit changes. Suppose you remember any formula, in that formula mass comes. But if I am writing that formula, I am not writing the mass. It means now that quantity is for per kg. For example, if I say you potential energy is equal to GH and that came as 10. It means what? By default, you understand that gravitational potential energy formula used to be mgh, but I am only giving h. It means what? This is for per kg. It means joule per kg. Okay. So that is the meaning of specific. But why did I start this topic? Because this is the general perception among the student. If anything is being specific, just divide by m. But no guys, there is one property I will show you. Now I'm changing the page. Suppose you are looking for a specific volume. Yeah, that's correct. You will do volume by mass. Okay. And a specific volume in our gas dynamics and in our jet propulsion, rocket propulsion, it goes like this. 1 by rho. Why? Because you should know this. Mass is equal to density into volume. Correct? So send density this side, send mass this side. I hope you understood this. Okay. So what I'm trying to say is specific volume is that normal procedure what I just explained on previous page. But now I'm going for another one which is specific weight. In a specific weight is actually divided by volume. So it is memory based thing. So you should know weight is equal to mg divided by v. And if you do this m by v, see I am teaching from very much basic. Still if anything is missing, you guys should cover that part, because I don't know how weak you are. I am trying to teach everything from scratch. If you have no idea what is volume, what is mass, improve that part, okay? Now mass into volume, just now we have seen mass by volume is actually gravity, so rho into g, correct? Now see here, in GATE exam, rho g, they may give you together as the word specific weight. They may not give you rho separately, g separately. They can say that specific weight of this liquid or this thing is this much, okay? Now I can give you based on this you can solve a lot of things, like in rho gh, this is highly used because rho g part is because rho gh is the formula for hydrostatic pressure we have seen in last class, right? Okay, so we are clear with specific weight. I will give you one more property, that is specific gravity. Specific gravity is very, very important. I'm changing the page. See now, specific gravity. In specific gravity, we discuss this in two ways. Okay, specific gravity for liquid is different, and specific gravity for gas is different. Yes, it is also known as relative density. Very good. I was about to say that. It's very good that you are recalling everything. Specific gravity is also known as relative density, and it for gases and for liquids, they are different. What is the meaning of this? The word is here, relative density. In case of gases, if you want to find out specific gravity Sg, suppose you are looking for any gas, suppose that is any gas, we can say, suppose take CO2. Suppose you are looking for the gas CO2, then you know what to do. You write down density of CO2 and divide that density with density of air. But here this air density is very standard density. You have to use only one value, 1.2256 kg per meter cube. And you know, this density of air also changes with temperature and pressure, because air is a gas is compressible. So you have to make sure what was your temperature and pressure. So 288 Kelvin and 1 atm. Only at this coordinate, air will show you this density. Then only you can find out the correct specific gravity. Okay. Always you have to use this data of air to calculate specific gravity, that is relative density. Now in case of liquids, what happens? Suppose you are looking for specific gravity of oil. So what you have to do, density of oil divide by density of water. But again, challenge here, this rho you have to take 1000 kg per meter cube. And you know, because water is liquid and liquid is not as compressible as air, correct? I mean, as gases are more compressible. It means in case of gases, pressure matters a lot, but in case of liquids, pressure does not play a very important role here to define this definition. So we only bother about temperature, that was 4 degrees Celsius. Okay, what is 4 degrees Celsius? 273 plus 4, that is 277. I hope you understand this. Now, nowadays in GATE exam, from last 3 years, they are asking one question which is based on data. Okay, like 2022 GATE exam, they asked density itself at, I think at mean sea level they asked. And in 2024 this year, they asked your service ceiling altitude. It was a very simple problem. 100 feet per minute something was the data, but they gave 50 feet per minute. Okay, so data is also important. It means what? Every corner of your syllabus should be on your fingertips. Then only you can achieve 60 plus marks. Otherwise, I can give you in written. Touching 45 to 50 marks is very, very tough in GATE exam if you are misbehaving with your routine. Changing the page. Now we will understand a concept, that is thermodynamic equilibrium. What do you mean by thermodynamic equilibrium? I'm sorry for the handwriting. Please take care. Thermodynamic equilibrium. What is that? See, we are discussing a thermodynamic system. What kind of system is thermodynamic for us? We have aircraft, we have wing in the aircraft, and engine is installed at the bottom surface of the wing. In some fancy or private jet aircrafts, engine may be mounted here also, near to the tail. These things are design criteria. Don't bother about that. I am trying to take your attention on the engine part. Inside the engine, what is happening? Suppose this is your engine part. Air goes into the engine and comes out as a combustion product, right? Now in this combustion product, whatever things is taking part, from here fuel is coming, from here air is coming. So you should know the details that the system is in thermodynamic equilibrium or not. If system is not in thermodynamic equilibrium, then what kind of damages system can experience, or what kind of changes you have to make in your system. Let's understand thermodynamic equilibrium first. Changing the page. So today, if meeting gets over after 40 minutes, I have not prepared that 3 question, because today I'm very sorry, I was very busy. I took 2 interviews of old students. Those interviews I will upload on YouTube. So because in this time only I have to take interview also. So one interview I have uploaded. Vanshaj, he joined IIT Kanpur last year in aerospace department. So that's why I could not find time, because I was editing and all. So today for 10 minutes, just revise previous classes. Now I am going ahead for thermodynamic equilibrium. Suppose you have a system, that system name is A. That system, this system is going to interact with system B. Okay. So in how many ways system can interact with any other system? That is main point. There are 4 ways a thermodynamic system can interact with another thermodynamic system. Okay. First way is in terms of temperature. If they are interacting each other, heat supply may or may not be there. Okay. If heat supply is there, from one system to another system, heat supply can be in any direction. Okay. It can be from here to here, depends on temperature. Okay. So this kind of interaction comes under thermal equilibrium. So system should be in thermal equilibrium. There are 4 interactions. So if all the 4 people are in equilibrium, then only you will say that system is in thermodynamic equilibrium. Don't be confused. I am saying thermal and then I am saying thermodynamic. Thermodynamic equilibrium I am teaching. Thermodynamic equilibrium contains 4 different types of equilibrium. In that, one is thermal equilibrium. So I will explain what do you mean by thermal equilibrium. I am changing the page. So first one, you have to understand what is thermal equilibrium. Suppose you have a system A and this system is interacting with system B. When I say interaction, what do you mean by that? When I say interaction means, suppose you have a hot tea. In that you mix some cold milk. What will happen? Milk is at different temperature, tea is at different temperature. So when they will interact each other, heat exchange means temperature change will come into the picture, right? It means what? System is not in thermal equilibrium. It means what? If you will do certain study, then you have to take care that a system was not in thermal equilibrium, then your study will become more difficult. So what happens here? We see simply that when A and B, they are interacting with each other, they should not share the heat. I hope you understand. It means what? Thermal gradient should not be there. Temperature gradient should not be there. Now suppose I have only one system. In this big system, I have a liquid from here to here, from here to here, from here to here. And suppose here you have applied one thermometer, you are getting different reading T1. And at different location, you have applied thermometer, you are getting different temperature T2. It means what? Temperature is not uniform in the system. It means what? Thermal equilibrium is not present in the system. I hope you understand. So uniform temperature should be there everywhere in the system. No temperature gradient should present in the system. What do you mean by temperature gradient? Temperature gradient is nothing but whenever gradient word comes into picture, it means divide by distance. Suppose at this point A you have temperature T1, at this point B you have temperature T2, gap between them length is AB. So what do you mean by temperature gradient? T2 minus T1 by length AB. This quantity we say temperature gradient. And when the gradient will be zero? Gradient will be zero if T1 will be equal to T2. Means everywhere uniform temperature. Same thing goes for pressure gradient, density gradient. If you have done flight mechanics or aerodynamics course in your college, you may have heard there is something called adverse pressure gradient. All these things I will explain when we will be discussing core of aircraft propulsion. Okay, they are very important. So currently from last 3 classes, I am only going down and deep down into the fundamentals of thermodynamics. Once we are okay with this, then we'll be very comfortable in propulsion core. Changing the page. So first was thermal equilibrium. Now second we'll say as equilibrium, that is chemical equilibrium. Chemical equilibrium. What happens in chemical equilibrium? What happens? So suppose I have any liquid like this. So I am collecting sample of the liquid from this corner and sample of the liquid from this corner. I am testing in the lab. Then here formula comes C2H4 and here formula comes C2H6. Okay, it means what? In this different types of molecules are present. It means what? Actually, we don't have uniform chemical composition in the matter. If you don't have uniform chemical composition, then this system you will say as it is not in chemical equilibrium. So you should have same molecules. That is one thing. What is that? Uniform chemical composition. Okay. Now next, suppose you are taking care of this. Means you have uniform chemical composition. For example, you have a cup of tea and you have water. Very good. And you have mixed sugar. But sometimes what happens? Sugar will be like water will be more sweet in the last. Why? Because more sugar molecules. Here also you have sugar and water molecule. Here also you have sugar and water molecule. But here concentration is different. So that kind of situation is also comes under chemical equilibrium because it is related to the molecules. So this time we say no concentration gradient. Again gradient is coming into picture. No concentration gradient. And next, chemical reaction should not take place. Okay. So no chemical reaction. Chemical reaction should not take place. So this was the second type of equilibrium. Now we'll go for the third one, and the third one we say as mechanical equilibrium. Mechanical equilibrium. Very simple. In case of mechanical equilibrium, sum of all the forces in x direction should be 0. Sum of all the forces in y direction should be 0. And if you are considering third direction as z, for that also you should write sum of all the forces in z direction 0. And sum of all the moments should also be 0. Now here interesting fact come into picture. In mechanical equilibrium, why do we say forces separately and moments separately? Very fundamental question. Okay. Why do we say sum of all the forces and moments should be 0? We know that forces are the one who produce moments. Then why I am adding moments separately? Okay, so actually meeting got over. So after 40 minutes we are meeting again. So that I say as second half of the day. So now see, I was explaining mechanical equilibrium and I was raising a question, why do we bother that in mechanical equilibrium all the forces must be 0 and all the moments must be 0? If I only say that forces are 0, then why another need to say moment is also 0? Why? Because we know that force is the person who is going to create moment. And if already I am saying force is 0, then why I am saying again moment is 0? So good example. Suppose you have a rod. Okay. And you are applying a force of 10 Newton here and a force of 10 Newton here. So in this example, if you calculate final force, so 10 upward, so upward you consider positive force, okay, then plus 10 downward automatically negative, because any one direction will be negative. So final force is coming 0. But about this point, this guy will start rotating. Okay. So you can clearly see force is 0, but still motion is there. That's why we separately say all the moments should be balanced. Okay. Means if all the forces are 0, does not mean that moment will also be 0. Right. Now I am going to explain you the concept of fourth one, that is phase equilibrium. Very interesting and simple. Phase equilibrium. What is the meaning of phase equilibrium? Suppose I have a system. In this system, I have taken 5 kg something in gaseous state, 3 kg something in liquid state, and suppose 1 kg something is in solid state. So these values should not change with time. Okay. If phase is maintained as it is in their values, then you will say there is a phase equilibrium. If, for example, if solid is melting and converting into liquid, then after some time we will lose this phase. I hope you understand this. So that's why we say phase equilibrium. Let's understand very important process of the thermodynamics that we say as quasi-static process. QUASI, quasi-static process. What do you mean by quasi-static process? This is important. So in quasi-static process, static means stationary. Okay. And see, quasi means almost. So quasi means almost. Okay. And yes, absolutely right. Infinitesimal slow process. And static means you can say rest or stationary. Okay. So almost stationary. Another technical word, what Kajal said just now, infinitesimally slow process means process is running, but infinitesimally slow, very slow. For example, growth of hair. Today after 1 year I took haircut, today only. So today I took 2 interviews. One interview in long hairs and then haircut, and then in short hairs. And only like my mom is saying I'm looking like Shah Rukh Khan yet. Now see, in this almost rest or infinitesimally slow process, we find few things very interesting. What are they? Guys, whenever there is a process, suppose this is PV diagram, whenever there is a process, it will follow different states. Okay, so suppose this is your process. So in this process, different states are coming. And quasi-static process is that process where it is very slow and every state is in thermodynamic equilibrium. I hope you understand that. That's why before quasi-static process, we learn all the 4 types of equilibrium, and a system is in thermodynamic equilibrium if all the equilibriums are satisfied, and these states will be in thermodynamic equilibrium if the process is quasi-static process. So quasi-static process is a thermodynamic process that proceed very slow, infinitesimally slow, so that every state is in thermodynamic equilibrium. This process is also known as reversible process. Reversible process. Okay, what do you mean by reversible process? I will explain very soon. Students, understanding of reversible process and irreversible process is very important for GATE aerospace and any aerospace engineer, even if you are not applying for GATE exam. I will give you perfect physical feel when this topic I will take in detail. So currently you understand quasi-static process is reversible also. Later I will explain what is the meaning. Now I am going to discuss what are the types of processes, because now we are going to detail. So types of processes. Okay, new heading. Now I am going to define the process based on some features, based on some changes. So based on reversibility, I will define the process. In this category, I have two types of process. One is reversible process and another one is irreversible process. What do you mean by reversible process? Now it's the right time to explain. Imagine that you have a system. In this system, inside you have 100 Kelvin temperature. Now this system, I'm going to explain what is reversible process. Now this system is sending heat out. So suppose some 20 joule heat came out. Now because of this 20 joule heat, surrounding area will be affected, correct? So suppose when heat was not there, that time temperature was T1 is equal to 30 degree, and when 20 joule heat came out, that time surrounding temperature T2 became 35 degree, and inside take everything in Kelvin, otherwise because of explanation I could not take care of units. Suppose 30 Kelvin and 35 Kelvin, just an example. So what do you mean by reversible process? Now send this heat inside exactly 20 joule and everything should set to its original value, to its previous value. Then you will say the system is reversible system. It means what? When 20 joule system is going back, when 20 joule heat is going back to the system, then any traces should not be there. Which traces? What kind of traces? That some heat came out. Because of that, these molecules got disturbed, and when this heat is going back, these molecules should come down to their original position and situation. Okay, this is the meaning of reversible process. But in real applications, any process is not reversible. Process is irreversible. Okay, now to compensate that irreversibility, you have to pay extra. Let's understand what is the meaning of that. Now see, suppose this was a system with 100 Kelvin temperature. Now some 20 joule heat went out. Because of that, outside temperature changed from T1 to T2. Now I am sending this heat inside again 20. But I am not reaching to T1 temperature. I am reaching to some T2 dash temperature. It means what? From T2 to T2 dash, but I have to reach to T1. So this gap what you are not able to overcome, that we say irreversibility. Okay, and irreversibility present in any system we must know, then only your device will be proper device. Okay, what do I mean? Every one of you may have heard about, there is something called CFD. Okay, every one of you may have heard about something called fluent. So suppose you are making, changing the page, suppose you are making any airfoil in fluent and you are sending one air from here. Okay, and some of you may have done this program in your college time. So suppose you are confining a zone. I hope you understand what I'm trying to do. We do this in ANSYS. Okay, so at the inlet you are giving certain velocity. Suppose this velocity is v1 is equal to 10 meter per second, and at the exit you are measuring the pressure. Suppose here you measure pressure p exit is equal to 10 pascal. Just understand, 10 pascal you measured. Okay, now same airfoil you try to develop in real life, and then same 10 meter per second you send. Do you think 10 pascal will be there? No. Why? Because here lot of things we cannot conclude, we cannot include in the analysis. Lot of realities we cannot include. What will you include? Surface friction you will include, gravity you will include, blah blah things you will include. Do you think exactly 10 pascal will come at the exit? Never. Never. Some changes will be there. Why? Because system is not reversible. So okay, you understood that there is something called reversibility, there is something called irreversibility. But in real life, what are those causes? What are those factors causing irreversibility in real life system? Okay, I hope you understand that what I'm trying to talk. So reason for irreversibility. Reason for irreversibility. If these people will be there, system will be irreversible. First, if there is heat transfer. Second, if there is friction. They both are different, guys. And for aerospace department, yes, you are right, Kajal. And in aerospace department, only these two plays very important role. But of course, when we say friction, mostly it means we are talking about solids. But in case of liquid, same friction we call as, can anyone tell the name?
Viscosity.
Perfect. Viscosity. If viscosity is present. Very good all. Now, there are some different branches of engineering. In those branches, irreversibility comes because of different phenomena. For example, I am giving you plasticity. Because of plasticity, or you can say plastic deformation. What is plastic deformation? Suppose you have two molecules, but they are plastic molecules. They are at x1 distance. You applied some forces and they went away to a new x2 distance. But when you removed your forces, they did not come back to x1. It means still some distance was remaining to cover. That distance is creating irreversibility. Means, I hope you understand. Right. So in different branches, different factors can be the cause for the irreversibility. Now, fifth one I'll try to explain. That is, in electrical department, we have resistance. In electrical department itself, magnetism, or you can say in core physics also you have magnetism. In magnetism, hysteresis plays very important role. You may have seen this graph in your 12th class when you were preparing for, if you have prepared for IIT JEE, you may have practiced this hysteresis loop. This goes like this and it comes like this, something like this. This is not perfectly correct, but arrows are there, like this it goes. Okay, hysteresis you may have heard. So these people, and in thermodynamics we have spontaneous mixing of substances at different composition. Suppose you have okay, very good example. You know that in a rocket engine, I'll give you very relatable example. In one chamber we keep fuel, in one chamber we keep oxidizer. Can someone, okay, I'll ask, then we use some compressor and turbine system here. So from this we bring fuel, and from this we bring oxidizer, and then we have another pipe, and this pipe, mixture of these two people comes into this pipe. Can someone tell me what is the name of mixture of fuel and oxidizer in rocket propulsion? What is the name of fuel and oxidizer in rocket propulsion?
Propellant.
Propellant. Very good. Perfect. So we say propellant. Okay. So we have propellant. Now this propellant, so you can see, because mixing is taking place, so definitely system is irreversible system. Okay. Later I will tell you that there are so many ways in mathematics to calculate this thing, irreversibility. And when I'll be teaching you second law, that time I will tell you that how will you measure irreversibility. So entropy was the new physical property which measures irreversibility. Why do we learn entropy? Entropy is nothing but, like we have distance. To measure distance, we have a quantity. Okay. From here to here you are going. How will you say that? You will say, now you are traveling distance. Okay. Like you have temperature. You measure temperature also. You measure pressure. So in same way, how do you measure irreversibility? Entropy is the measure of irreversibility. Okay. And where do you have irreversibility? In real systems, you have irreversibility. In ideal system, you don't have irreversibility. Okay. There are some more causes. Chemical reactions are causing irreversibility. Free expansion is also causing irreversibility. What is free expansion, guys? This also you may have heard in your engineering days. Suppose here you are packing some gaseous molecules, and here you have a chamber, gases cannot cross, and that's all, wall closed. In this zone you have complete vacuum. So when you remove this line, I mean this chamber you will open, then these gases will rush in this direction. Okay, this is called free expansion. So right now system is at particular state. Suppose that is T1 temperature, P1 pressure, V1 volume, ρ1 density, H1 enthalpy, S1 entropy, okay, U1 internal energy. These things are the values of the state right now. But when you will remove this wall, these people will rush. Now they can never come back here. Why? Because it was vacuum. Because of vacuum, they got sucked into this zone. Okay, they got sucked into that zone. But now they cannot come here automatically, right? So they can never achieve this system. So that's irreversible. So free expansion is irreversible. Okay. So this was the types of process in that I was talking about reversibility and irreversibility, and I discussed types of irreversibility in detail and what can cause irreversibility. You see guys, in GATE aerospace exam, they can give you one question, which of the following is or are the causes of irreversibility, and 4 options they are giving. So if you don't know this, or maybe I am not teaching you all causes, but if your brain will not work, then you should be able to think, right? Oh, what is the meaning of irreversibility? Why irreversibility? Molecules cannot come back to their original position. If you reverse the this thing, then you will say, okay, it is a irreversible process. I hope you understand this. But what? But in some part of it is using, yeah, right. But when you are using external force, then you are taking back to its original position. So in that case, I am not saying that you cannot go to your original position. You can go, but you have to pay something. Okay, you have to pay something extra. You have to pay. That is nothing but because there is irreversibility. To overcome the irreversibility, we are spending a lot of fuel, right? Work and all, everything. That's why we are constructing. So now I am going to have the second thing based on process index. Based on process index. What do you mean by based on process index? See, what do you mean by process index? PV power n, okay, PV power n is equal to constant. This n is known as process index. You may have heard PV power gamma is equal to constant. This gamma is process index. Which process? Adiabatic process. That's why this gamma is known as adiabatic index. So we have several processes based on this gamma. I'm sorry, based on this n. N can be 0, n can be 1, n can be equal to gamma. Gamma itself can be for it can be for monoatomic, for diatomic, for triatomic. For monoatomic, I have forgot the gamma value. I think it is 1.56 or 67 something. For diatomic, it is 1.44. For triatomic, it is 1.33. I'm sorry, it is not 44, it is 4, only 4. And for triatomic, it is 1.33. Okay, thank you, Kumresh. For monatomic, it is 1.67. So, guys, keep in mind, for monatomic, it is 1.67. Because gases can also be monatomic, diatomic, triatomic, right? And for n is equal to, you can have something else like n is equal to infinite. These processes, you know, on PV diagram, if I draw these lines on PV diagram, then how will it come? So first you can draw a straight line that you will say as isobaric line. Why? It is isobar and process isobaric process. Why? Because pressure is constant. Okay. If pressure is constant and it is isobaric, then you will say here n value is equal to 1. And just vertical line, if you draw like this, this is called isochoric. And in isochoric, your n value becomes infinite. Okay. Oh, sorry.
Sir, isobaric mein n
I'm
equals
sorry.
to 0.
I'm sorry, by mistake. This should be 0. Thank you. This should be 0 and this should be infinite. Now, if you do this line, which is a minute, I should draw like this. You can say n is equal to 1. So this is isothermal line. And you can see for n is equal to 0, line is like this. For n is equal to 1, line is like this. So if I increase the n value, line will go like this. So this is n is equal to gamma line. Okay. Now I can ask you, because in this direction as in n is increasing, and if this gamma I say 1.4, then you can easily judge, it means this will be your n is equal to 1.33 and this will be n is equal to 1.67, right? Because n is increasing, and when you will reach vertical here, you will be getting n is equal to infinite. Everything is clear? So how many popular processes you may have heard? You may have heard isobaric, you may have heard isochoric. Pressure is constant, volume is constant. They are also known as constant volume process, constant pressure process, constant temperature process is isothermal. Okay. Now you may have heard adiabatic process. There nothing is constant because heat is not transferred. So you will not say heat is constant. Heat is not a static property. Heat is not a point function. So you cannot say heat is constant. So you should say heat transfer is 0. That is adiabatic process. I am not teaching process right now in detail. I'm simply saying that these are the types of processes. Okay, in future I'll be teaching you isentropic process in detail, and isentropic process is your main process what you have to learn throughout your jet propulsion in detail. Slowly you'll be very good in all the processes. These people you will not practice a lot, but the way nowadays they are asking GATE question paper, they can ask any one problem from these processes. So we have to understand numericals on these processes also. I will take this process one by one, but today actually I am explaining types of processes. I am not explaining details of the processes. So now based on third one, now based on volume and pressure change, we have processes. That process we say expansion process, where volume will increase and pressure will decrease. You have compression process. In compression, volume will decrease, pressure will increase. Okay. Expansion is sometimes also related to velocity. Expansion is sometimes also related to velocity, that we will discuss in gas dynamics. Okay. Now I will discuss, okay, these are the types of processes. In future, in upcoming lectures, we will discuss details of the processes and we will solve numericals also. Like I will give you a question, there is a container and with pressure and temperature this much, pressure became this much, now what will be temperature? These kind of questions we will discuss in detail. Now I am going to talk about energy, very important. Guys, energy will be last topic of this lecture. See, like you know, I am Hindu by religion. In our religion, when we say about God, we say about which God? Okay, Ramji, Krishnji, Shankarji, which God? Right? So in same way, when you say energy, energy is not something like only energy. Energy has some form. Okay. For example, when you say I need food, I am hungry. Which food you want? Roti, chawal, pizza, samosa, kya chahiye? You need some form, right? There is nothing called food. Food is always present in some form. In same way, if you will go and ask energy, they will ask which energy you want, form of energy. Okay. So first of all, what is energy? Energy is nothing but, if you have energy, you can do work. If you have energy, you can do work. So tendency to do work is only called energy. Tendency to perform work is called energy. You have several forms in energy. So we will discuss those forms, but I want to discuss energy at two levels. At MACRO macroscopic and MICRO microscopic. At macroscopic, we see several formats. We see kinetic energy, potential energy, heat energy. So I will mention them. And that's what depends on reference frame, I say. Like in which frame you are seeing. At microscopic frame you are seeing, or in macro or micro. So in micro also, molecules are having kinetic energy, one single molecule. And two molecules are together, they have certain mass M1, M2. then they'll be having their potential energy also. You may have heard in 12th class, potential energy of charged particle, Q1, Q2, 1 by 4 pi epsilon naught, Q1, Q2 by R square. This was the formula for potential energy between two charges, right? So we can do all these things in this kind of detail, that you can have energy in several ways. Those ways we will discuss. You can have energy which is stored. You can have energy which is moving. For example, in your electricity, you have battery. In that battery, some energy is stored in the battery, and those energies we are using wire. Okay. If that energy is not stored, how can you use? But there are certain energies they can never store. For example, work and heat. They are always in transient form. They are not storable. Okay. So if you say energy, then energy itself is having on what basis? So on reference frame basis, if you divide energy, then you have to divide energy at MACRO macroscopic and MICRO microscopic. Okay. In macroscopic, you have two types of energy, that is kinetic energy and potential energy. Okay. Now, when you talk about microscopic, again you can say based on degree of molecules. Based on degree of molecules. What do you mean by degree of molecule? Monoatomic, diatomic, triatomic. You will be having different types of energy, and based on activity of the molecules, you will be having energy. Anyway, these things you don't have to focus. Even this is you don't have to focus. Simply just for idea. And based on storability, you can store or not. Based on storability, if you can store, then you will say stored energy. You have stored energy. Otherwise, you have transient energy or energy in motion or transitional energy. Okay, in motion. Both you know very well. In broken words, you know. So in next class we will start with internal energy and its concepts. Very, very important. For time being, you understand it is the function of temperature. Okay, that's all. Class over tonight, and ask your doubts on WhatsApp now. I'm switching off this. But okay, right now if you have any doubt, you can ask right now from today's class. Let's start.
So can you explain the state and phase once more? I didn't understand.
Yeah. Suppose you have liquid. So liquid is a phase. Okay, but this liquid can be at T1 temperature, at T2 temperature. So these are states of liquid. Okay, you can also say they are actually, it's not like yes, I can explain gradient also. See, if you have any property, suppose that is temperature. So if you walk on the path and you see that temperature is not same, it is T1, T2, T3, then you will say temperature gradient is present. Okay, temperature gradient is present. I have made a very old video on YouTube. There I have taught gradient of property. Please watch that video. You write like that, density gradient, or you write heading temperature gradient concept library. You will get that video and you watch in detail. But right now I'll explain because you have asked. So suppose here you have distance x is equal to 3 meter, and here you have distance x is equal to 4 meter. Suppose not 4, suppose 5 meter, and suppose here x is equal to 0. So when you traveled from here to here, from 0 to 3, you found that everywhere temperature T. But suddenly after 3 you reached 5. So temperature here was T is equal to 10, here 15, and here 20. So you found that temperature is not constant here. So if temperature is not constant with respect to distance, with respect to path, with respect to location, coordinates, then you will say temperature gradient is present. Same example you can say for density, pressure, and other properties also. But suppose I have a position here, and at that position x is equal to 3 meter. Right now temperature is 5. But after certain time, and now I'm saying time, temperature is 6, 7. With time, temperature is changing. This is not gradient. Gradient is only with respect to the distance. I hope your doubt is clear. But you watch that video what I have explained, because there I have explained vector also related to gradient. Please watch that video. Write keywords like this: temperature gradient or something, density gradient, pressure gradient, concept library, something you write and you will get it. Yeah, see, if you will go to more deep about this, it makes actually no sense. State and phase, they also come in synonym part. Okay, they also come in synonym, because in your childhood you may have heard this topic, states of matter. Okay, there we discuss solid, liquid and gas. But when you learn graphs, okay, so this is at this coordinate PV graph, your state is P1 B1, your state is P2 V2, your state is P3 V3. But these pressures and volumes, they are state and they are changing, but they all are for the liquid. So phase is not changing, states are changing. So don't be confused. I hope you understand this.
Sir.
Yes, ask your doubt.
Sir.
Yes, ask
Yes,
your
sir.
doubt.
Sir, these are thermodynamic states.
Yes, yes.
Otherwise,
Otherwise,
I'm asking about states of matter like solid, liquid, and gas.
okay.
And when a body is in solid state, can it attain like other phase? Like it will be in solid phase or liquid phase. That
No, I didn't get your
and
last.
is also in the context of.
Ask again.
Sir, like sir, like there are states of matter: solid, liquid, and gas.
Correct.
And similarly, can we differentiate like there are phases like solid phase, liquid phase, gas phase? Can we mean the same? Both?
No, they are same. They are same.
What
They
is
are
the
same.
difference?
No difference. That's what I was saying. That state of matter, if you say, that is the same thing you are trying to say phase of matter. But in thermodynamic graph, state is different. But in this heading,
Yes, sir, that
state
is
and phase.
thermodynamic state.
Yeah. But in this heading, state and phase, they are same.
Sir, but is there in the context of phase equilibrium? Sir, how do we?
No. Don't be confused. State means in thermodynamics you are learning, right? So you in thermodynamics you be here. You know that these points are states, coordinates, and phase. You understand? Solid, liquid, gas. They are phases. Okay. Matter.
Sir, condition for phase equilibrium.
Yeah, I said na, in phase equilibrium you have phases. You have phases. You have solid phase, you have liquid phase, and you have gaseous phase. All those phases are not changing their amount. Then you will say phase equilibrium. Right?
Yes, sir, got it.
Okay.
Yes, sir.
Okay. Next doubt? Process of attaining equilibrium state, and if the entire process is irreversible. There may be, because very subjective question this is. There can be situation or not. Because that is very deep question from thermodynamics, so I don't want to bluff anything. Okay, you guys can study if you have more detailed doubts. Let me know your questions. Okay, then I hope you are, because you're not asking questions, so I hope I can end the class. Okay, thank you all of you. Good night. I'm ending the meeting.